operation on limit and limits of composite functions. The standard rules for finding the limit of a composite function looks something like this. If limit of g of s when s approaches a equals k, and f of s is continuous as s equals k, then the limit of f of g of s when s approaches a equals f of limit of g of s when s approaches a. Alright, we will expand upon the idea of continuity later in the unit. For now, think of f of s is continuous as s equals k. If f of s has no holes, prefix or asymptotes as s equals k. While useful, this rule can be very problematic if the inner function limit does not exist, or if the outer function is not continuous at the value of the inner function's limit. Now, example number 2. Consider the graphs of a function f of s and g of s given below. Find each of the following limits. Now, question A. Limit of f of s when s approaches 1. Alright, so we need to calculate the limit of the inner function first, which means this guy. So we have the limit of f of s when s approaches 1, right? So when s approaches 1, it's going to be right here. The limit of the function approaches 3 minus y, because it's going to be below 3, look. Right? So this one equals 3 minus. Now we're going to check the outer function at 3. So since the outer function f of s when s approaches 3 discontinuous right here. You see that? The outer function must be continuous, and then we're going to apply this one. So because this is discontinuous, we need to keep taking the limit. So it's going to be limit of the outer function f of s, right? Which means this guy right here, when s approaches 3 minus. So 3 minus is going to be the lower one right here. The answer is 1. So finally, you need to conclude that limit of f of s when s approaches 1 equals 1. Alright, let's move on to question B. We need to calculate the limit of the inner function first, right? So limit of g of s when s approaches 3 is going to be right here, right? Right as s equals 3, you see that upper half is going to be this guy. Lower half should be this guy, right? So the function approaches 0 plus and minus, right? This one is 0 plus, this one is 0 minus, right? 0 right here. Now we're going to check the outer function f of s, right? This one is the outer function f of s when s approaches 0, right? So we look at this one, it's going to be undefined, right? So you need to calculate the limit of the outer function f of s when s approaches 0 minus. It's going to be right here, right? 0 minus, which means 0 to the left, so we're going to take the lower one. It's going to be 1, right? Now similarly, limit of the function f of s when s approaches 0 plus, it's going to be this guy right here, right? 0 to the right equals 2. Right? So since this guy different, right? So the original limit right here does not exist. Now let's move on to question C. Limit of the function g of f of s when s approaches 7, right? We need to calculate the limit of the inner function first, right? So limit of f of s when s approaches 7, right? So we look at the function f right here, s approaches 7 right here. left side or right side, they both approaches infinity, right? So this one equals infinity, right? Now we need to calculate the limit of the hammer function, which means g of s when s approaches infinity, right? So g of s when s approaches infinity is right here. When s goes to the right, the function approaches horizontal asymptote right here, right? 2. Then finally the answer already must be 2, right? Now we're gonna move on to the last one. The last one is so complicated. From the graph below, find the limit of g of f(s) when s approaches 1. So we need to calculate the limit of the inner function first, right? So we have limit of f of s when s approaches 1. Right? So we look at this one. When s approaches 1, we need to split this one into two limits, right? Limit of f of s when s approaches 1 minus equals 1 minus, which means this guy right here, right? It's going to be negative 2, right? Because this one 1. So this one equals negative 2. Now, limit of the function f of s when s approaches 1 plus 1 plus, which means 1 to the right. So it's going to be right here equals 1, right? Now observe that limit of f(s) when s approaches 1 minus not equal to the limit of f(s) when s approaches 1 plus. So then the limit of f(s) when s approaches 1 does not exist. Alright, now a lot of students make mistake. They're gonna say that the limit of the inner function does not exist. Then this one does not exist. This is not the case. You need to get rid of this mistake. Alright, look at this one right here. If the limit of the inner function, which means limit of f(s) when s approaches a does not exist, it does not automatically conclude that limit of g of f(s) when s approaches a does not exist. Instead, you should investigate further the existence of the limit of the composite function. Limit of g of f(s) when s approaches a depends on the behavior of the function g near the values that f of s approaches as s approaches a, including one-sided limits if applicable. Specifically, if the limit of f of s when s approaches a does not exist, which means due to different left and right limits or unbounded behavior, which we just did right here, right? The inner limit does not exist. Check the one-sided limits of the limit of f of s when s approaches a plus and limit of f of s when s approaches a minus. Then evaluate g at one-sided limits of f of s if they exist and g is defined there. The limit of g of f of s when s approaches a exists only if the values of g at the one-sided limit of f of s are the same and g is continuous at those points. Alright, so go back over here. We need to check for the left and the right limit. Alright, now we're gonna go back to this question right here. When s approaches 1 minus, the limit of f of s approaches negative 2 minus. Why? Because it's gonna be negative 2 below. Look, this one, right? So you need to be careful. Similarly, limit of the function f of s when s approaches 1 plus, which means 1 to the right. The function approaches 1 plus, right? Because the graph is above 1. Look, so this one is 1 plus, right? Now, I need to calculate the limit of the function g of s when s approaches negative 2 minus. Negative 2 minus, so I look at negative 2, it's going to be right here. So negative 2 minus, because right at this point the function g is continuous, right? Look at this one, the function g must be continuous at those points. When you evaluate the value of the function g at the one-sided limit of LS, right? So right here it should be 2, right? Because it's continuous right here. So the answer is 2, right? Now similarly, limit of the function g of s when s approaches 1 plus 1 plus, which means this guy right here, right? So the function approaches 2. Now since this guy and this guy are the same, right? So we're going to go back to the original one. The answer for this one must be 2. So keep that in mind. And it's good time to stop. Thank you for watching. I hope you enjoyed the video. Remember that if you failing to prepare, you're preparing to fail.
We rise like tall buildings as the chemicals they take us higher. The night's young and it's just begun as she puts her hand in mine.